Another DraftScience video presentation and such. Anyway, alright, so I'll do comments and just go through some of this again. To start, I'll just make the simplest argument I can make in terms of explaining how it's catastrophically error, broken, incorrect. There's a catastrophic dysfunction in physics's notion of what energy is. And so the equation is 1/2 mv squared, and I have explained many times that the history of it is pretty terrible. The original formula was just this part, and then nearly 100 years later they decided to add this part. It wasn't derived from any of Newton's formulas. It's exactly an opposite argument against Newton mechanics. And it's just the fact that back when this was invented, science wasn't a real thing. Okay, science wasn't. You didn't go to NASA and say, NASA, do some experiments. So it was a little bit sloppy, and so people drew conclusions based on isolated events that took place in isolated circumstances, and there wasn't any context for those experiments. And so you can make something look like something, based on how you do an experiment, and that it's the whole idea is doing it clinically. So the idea is we'll take a spring. It's a reliable mechanism for collecting and redistributing energy. It does it fairly well. I could also just say let's use magnets, two north-facing magnets of sufficient strength, and they'll always give you the same thing. So if you push them together at exactly the same position, they'll give you the same thing back out every time. Same amount of energy, same joules. So let's understand this Newton and Joule thing. A Newton is the weight of an apple, 100 grams. So that's a Newton. That's how much that weighs, how much pressure that is. So if you put an apple on your hand. Now if you drop the apple from a meter high, that will be a joule. So a joule is like whatever, 10 newtons. It's a certain number of amount that'll hit the scale. So if I put the apple on the scale, I might get 1/10 of a pound. If I drop the apple, it might read 4 pounds. Okay, so it's not a huge distinction, but there's a certain number of newtons in a joule. But anyway, so if we're going to use their vernacular, we'll use whatever joules. I will use that number, but it's just a measure of weight. Momentum is just really your weight. You weigh more if you jump off a table, land on the scale. You'll weigh like 800 pounds, 4 times more. Okay, so you jump from a meter, you're 4 times heavier. That kind of thing. So that's a good way to think of it. A Newton is 1/4 of a joule. Yeah, because that's what it'll do to the scale. All right. Anyway, so continuing. So I put a 2-mass object. Okay, something twice as heavy as the next object I'm going to put on it. And all we're really saying is, look, I have the same exact spring. So I tested it. The springs are the same. Okay, and it really doesn't matter because I'm going to mark, what happens. So I compress this spring, all right, and I shoot a 2-mass object into this other spring. Now the fact is that if I do the experiment clinically, nice track, I make sure everything's nice and smooth, Teflon maybe, whatever. I can do this where the spring pushes with its reliable amount of energy, the ball moves into the other spring, and it compresses it just about the same. Okay, so let's say I might lose 1 or 2%. Okay, 1 or 2% of the energy. I won't get quite as much compression on this spring. Almost, but not quite. In the simple experiment, and so if I calculate the velocity of this, okay, it'll turn out to have, let's just say it'll have 1 velocity. All right, now all I have to do is lock the spring when I just mark it, and then I can recompress the same spring, and now I just put a 1-mass object on that same spring, same compression. Their physics says that this 2-mass object that compressed the spring exactly the same amount, okay, it only has, say, 250 joules of energy. It only weighs 250 pounds when it hits. and somehow this lighter object is going to have 500 joules of energy. And when it hits this other spring, you know, same spring it started with, this is the spring that made the energy, it's going to compress it more. I'm going to gain energy by throwing a heavy thing at a spring, replacing it with a light thing and having it shoot it back, and I will gain twice as much energy. Not a little bit of that energy. No, I will double the amount of energy I put in. The spring will actually somehow magically create extra energy somewhere in this process. Now, it's impossible. It can't happen. It doesn't happen. It's like, if this physics, if this simple experiment was put in front of Leibniz, he would have no way of explaining why that is, except to make up some kind of story about how, you know, springs are liars. You know, that they're not appreciating the special energy somehow. I mean, he really couldn't come up with any explanation. There's no way that can happen. It doesn't happen. There's no way this has twice as much energy in it, okay? It's no way that there's some magical river pushing it with twice as much energy. It isn't true. It's garbage. It's nonsense. It can't be correct. This formula is lopsided and stupid, and the simple truth is all there is your mass and how fast your mass is going. All there is the apple. Now, how fast can I make the apple go? And then it'll tell me how much it weighs, and that's its energy, its momentum. There's no other way to do it. This is, again, this is never right. It's always wrong. It's always going to lie to you. It's never going to give you the right answer. So, but again, people persist in making these crazy arguments. Now, to your credit, so to speak, audience, nobody has said, I'll pledge $500 in defense of conventional physics. Nobody's pledged anything. Nobody's willing to be proven wrong. Okay, they'll just assert they're right, but they're not willing to prove they're right. They're not willing to defend it because they know they'll lose their money. So, you know, it sort of grossly illustrates the duplicity that these videos exist out there where real physicists are telling this lie, I mean this completely fake story about how the universe works, like Physics Girl, silly things where they say, oh, the momentum was perfectly conserved and yet we lost half the energy. You know, just silly stories. And, you know, that's physics. Just, you know, and it's doing it overtly, and none of you have the integrity to defend it with some kind of rational argument that deals with the real world experiments. You know, the real experiments, not the ferrocell, not your, you know, we did it with clay, you know, the ones that work, the ones that you can depend on to be telling you the truth. All right, so with that context, let us move on to the comments. I'm just saying, if you're saying there's something, I've done something, again, you're saying I'm somehow cheating or lying. What's the lie? Okay, it's a simple experiment. You compress a spring, you shoot a heavy thing into another spring. It compresses it a certain amount. You replace the heavy thing with the light thing, and then you release the spring again. Where's the cheat? Your physics says one object has twice as much energy as the other object, even though they both receive their energy from one source. You know, explain it. Alright, so Bob contributed with, you know, it's not very useful in a sense, a 124 grain bullet. Oh, I have to go find out how much a grain is. Going at 360 meters per second has a momentum of almost 3 kilometers per second. So you didn't put it in joules. You should have just said it has a momentum of a certain joules. You should have just done m times v. You know, I mean, instead of 3 kilogram meters seconds. I mean, it's not very helpful. All right, anyway, however, it has a kinetic energy of 220 joules. Clearly, the momentum formula will say it has a momentum of whatever. Let's just make up a number, say 270. And obviously, their formula says, no, it's 520. The point is which one of those two numbers is accurate? Which one really is telling you how much energy it has? All right. The discrepancy between the low momentum and the actual effect seems strange to me. Well, the actual effect is the part where you shouldn't even be paying attention. Because the actual effect has to do with whether it's a hollow point bullet, or whether it's Teflon coated, or whether it's made out of steel, or, you know, lots of things will change with the effect of the bullet. So we're really, that's where the physics breaks down, because people are going, it seems like, you know, it seems like it's more energetic. That doesn't mean anything. It's all how, you know, clapping my hands, that's a joule. Okay, now what if I put an arrowhead on my palm? Yeah, it's a joule, but now it's going to create all kinds of damage. So all I have to do is change the shape of the energy, and I'll change the outcome. So, I mean, this is physics. You're not supposed to be making, you know, it looks like it's more energy. Yeah. Again, a pipe bomb. I take away the pipe. The bomb is nothing, right? I mean, it just goes boom, and a little bit of stuff flies around and stuff. No big deal. The pipe is integral to the fact that you're now going to create the same, it's the same energy, you're just going to make it do a lot more. So there's always the same energy in the gun, right? The charge, let's say. I mean, obviously bullets are loaded with different amounts, but I'm just saying, theoretically, if you cut the two pieces in half and just say you're going to have the same charge and you're going to shoot a different size cartridge, you know, it's always the same amount of energy. You can put different bullets in the gun and get different effects. Put heavy bullet versus light bullet. But the argument is what's the total energy of the object, and how much potential does it have to, if you were to disperse its energy in some perfect way where you could measure it perfectly, both objects, you know, that is, turn it into some little bits of energy that, you know, are spread out and averaged. The fact is, they both do the same. They both have the same potential to move atoms. All right. Discrepancy between the low momentum and the actual effect seems strange to me. I can't accept the silly notion of kinetic energy as an explanation. Well, it's not even that. It's not so much the notional silly part, is that it's overtly saying something that doesn't make any sense. Okay, but okay, whatever. All right, so then PSB says, what you are saying is wrong. First of all, if you are measuring momentum in newtons, so it just doesn't matter. Newtons and joules, it's all the same thing, right? I mean, a newton is the weight of the apple, right? And all I'm saying, a joule is, well, I gave that weight extra velocity. I gave that weight more weight. So a joule is just another way of measuring its weight. So it just doesn't matter it matters in the sense that, you know, obviously these are different, you know, one's 1/4 of the other, but they're all measuring the same thing. All right. All you're really doing is changing, in a sense, the mass of something when you drop it, right? We're saying velocity and mass are essentially interchangeable. You lower the mass and increase the velocity, you got the same thing as if you increase the mass. I mean, if you increase the velocity and lower the mass. It's all one thing. You're just measuring how much does it compress a spring. All right. Newton's, when you have no idea what a Newton's second law says. Well, again, Newton's second law, so this is, I don't want to draw it, but I mean, you know, this F equals ma thing. Now, mass is really easy. Acceleration isn't a thing. It isn't an amount. Okay, and especially when we're talking about exchanging it, right? I mean, the acceleration, even in the spring argument, is so minor an effect. I mean, obviously, the faster thing, the spring moves faster because it's able to move the lighter weight quicker. But acceleration is a total amount of something, and the acceleration is just proportional to how much energy you're capable of delivering. So, you know, acceleration, it's not very useful, in my opinion, to talk about what force is and then talk about acceleration, because the force, the total force, only cares about what your velocity is. So in the end, it just doesn't, and you know, again, to talk about acceleration when you have something like Newton's cradle, you know, where acceleration is completely meaningless. It happens so quickly. I mean, it's so near instantaneous, a transfer of the energy. Why would I even consider, how could I even consider acceleration as part of the equation? It's going to be velocity in the end. All right. Always referring to the second law of Newton gives the exact same result. So, you know, it's just wrong. But anyway, you can solve it on your own. So again, he ignores the experimental evidence and just keeps pretending that if he manipulates A's and B's and M's and switches them around in equations, he can somehow prove that this nonsense formula has some integrity. But that's not how the nonsense formula was invented. It wasn't invented by moving those things around. So that's just a nonsense. It was invented merely because gravity is incredibly biased to velocity. The more velocity you have, the more distance you'll travel through gravity. All right. Take two different masses with different velocities but with the same momentum. So they're exactly always have to be inverse. If they have the same momentum, they have to be inversions of each other. The amount of velocity you give to one has to be exactly the same as the amount of mass you took away for them to have the same momentum. So just understand that just means take two objects and just invert mass and momentum. I mean mass and velocity. To collide to the same spring, and you will see the compression, it will be different. So he just said it'll be different. So he just disagreed with this experiment. So just understand, he's saying that when I shoot the two mass object into the spring and I compress it a certain amount, okay, he's saying that when I put the one mass, and the compression is going to be almost exactly the same as this compression we started with. When I put the one mass on here, I will get more compression in this spring. It'll go back and it'll make more energy. 500 joules worth of more energy. I mean 250 extra joules of energy will be created merely by replacing a heavy thing with a light thing. Merely by doing the experiment a little differently. So he's saying the charge is different for the like I said, I could just reverse it. I could put the small object as the first object, and you know, then he's going to say somehow I lost half the energy somewhere. Even though we know the springs won't compress, they won't show you that loss anywhere in the experiment. The springs will look like they're producing the same exact amount, and he'll say somehow you lost 250 joules of energy just by moving the object to the other spring. So he's directly refuting this as a true description of actual reality. And that's exactly what I want, is people to say, yes, they disagree with this simple truth. And they think somehow you can make free energy. Alright, so just understand, just what he just said is nonsense. Okay, and the same spring, you will see that the compression, it will be different and will agree completely with the formula for kinetic energy. So I will see the spring compress twice as much if I just put a lighter object on the same other spring. So somehow light objects collect more of the spring's energy, or some kind of wacky theory. They can't, it's the same spring, so I mean I can't, you know, there's no way to get around it. It can't happen that way. Alright. So Bob says, replace Newton's kilogram meter per second. Also, did you read the rest of the comment where I pointed out the discrepancy between momentum? You should have just said what the momentum of the bullet is. Okay, I mean, you know, it's some number. Just say what momentum says. Okay. Of the projectile and the kinetic energy. Also, I can get some data on mass compressing a spring. Cheers. I don't know what that exactly means. And then PSB says, first of all, newtons is not kilogram meters per second. Well, it is, but whatever. You know, it really doesn't matter whether it's per second squared or any of that stuff. It's in the same exact quantities that you need, okay, in the sense that it's kilograms, meters, and seconds. That's all you need. So it can't replace Newton with this kilogram meter second because it's wrong. Well, says you. they're obviously they're made out of the same constituent parts. So measuring something's weight in even pounds is the same thing as measuring its momentum. Yes, I read it and I saw what you said. That seems strange to you, but it's because you don't understand it. Momentum and kinetic energy, they are not the same thing. They're describing the same thing, energy. One of them gets the right answer, one of them gets the wrong answer, because they get different answers. I mean, you could argue that both are wrong, but that would be absolutely silly. Momentum works just fine. Momentum is what got the, little orbiter on the moon. If they had used the kinetic energy formula to decide how much thrust to produce, they would have crashed on the moon. Okay, so any difference between them says nothing. See, how can you make any? How can you mean that? How can that make any sense? I mean, it is so poorly written. He's obviously, I guess, a foreign guy. But anyway, kinetic energy, they are not the same thing. So any difference between them says nothing. So he's trying to say that momentum and kinetic energy are somehow, there's some other way to, you could somehow have two ways to describe the same thing. How much potential does the object have to move atoms? Both of them are telling you how much potential does it have to move atoms. So how can they get different answers and it's okay? And that's crazy. It's so silly. You're saying, I mean, you really have, physics doesn't mean anything to you as a word, right? It just means religion or something. You can just make this shit up. They don't have to agree. The things describing exactly the same capacity, the numbers don't have to be the same. The fish can be 6 feet long and 3 feet long at the same time. Anyway, you don't need any additional data to masses, M1, M2, two velocities, V2, V2, and then he just sits there and does it again. Yes, things with the same momentum will create the same effect, but there's no way you can make things with different velocities with uneven masses have the same momentum. A spring with a constant K. I assume you agree with him that the two bodies, so here he says it again, will compress the spring the same. Okay, so his argument is, here it is. But if you solve it, see, this is where they just don't care about physical reality. All he cares about is some mathematical formula. And he's just going to defend it with another mathematical formula. He's going to say his math is right because his math is right. Some other mathematical equation is right. When, no, it's not. Okay, you've done a derivative that doesn't make any sense. You've replaced acceleration with essentially velocity and pretending it's the same thing when those two things aren't the same thing. You're pretending velocity and acceleration are interchangeable numbers, and they're not. All right, anyway. Okay, but if you solve it only with Newton, you will see that they will not. And the conservation of energy using the formula, so he just does it again, will give the exact same result. So he's disagreeing with what is just not, you can't disagree with it. As I just pointed out, it creates an insane paradox where all I'd have to do is create a system where a heavy thing is replaced with a lighter thing. So every time it goes back and forth, a pendulum, I just keep replacing, I do a little quick switch when it stops. When it stops moving, I do a quick switch, just put a lighter thing there. And then I can just keep creating more and more joules of energy by just replacing heavy things with light things. It's really stupid. I'm sorry, but that's the only word for it. It's so stupid for you to sit there and keep defending something and keep denying what you know are the experimental truth. You know that can't be true, that I couldn't make such a trick. I couldn't create a perpetually energy making machine. It's not even perpetual motion, it's perpetual energy creation. You know that can't exist. But that's the concept, the direct consequence of your imbalanced formula. I mean, you should just look at it and say it doesn't make any sense. How can I start squaring one thing and half the other thing? I know what mass and velocity are, and they're both important to a meteor. Only matters when it's heavy. right? I mean, it's not just its velocity, it's got to have the mass. If it doesn't have the mass, it can't mean anything. All right, anyway, the same momentum, so I said, the same momentum to collide, I just repeated what he said, which is, well, anyway, I'll collide to the same spring, we will see that the compression, it will be different. Okay, so again, it's the same spring, he's saying the lighter object will compress it more. The faster object, lighter, faster object will compress the spring more than the heavy, slower object. And it's completely wrong. It can't make any sense physically. It can't be true. So I said this can't be demonstrated with a credible experimental examples. This can't be demonstrated with any credible experimental examples, as evidenced by the fact that none have been provided. Momentum is essentially weight. A common scale essentially measures the momentum of objects. You're effectively saying two objects can have the same weight but not weigh the same. All right. So Ribble says, Ribble? Yeah, Ribble. I was correcting myself. I didn't say they were the same. So, I mean, he's apparently converting him into one of them. So he's apparently agreeing with them that somehow the lighter object can compress the spring more. Again, I just do the experiment right in front of your face with the same springs. You know, I do the experiment right in, light object and another spring compressed exactly the same springs, tension, compressed the same amount. I put a light object, I put a heavy object. I shoot them across to another set of springs. They're going to compress the springs exactly the same amount again. And obviously one object's going to do it much sooner than the other object, because one object's going to go twice as fast. But that's all that's going to be different. The springs are going to be compressed exactly the same amount because that's all the energy that's in the system. That's all there is. There isn't any place to get more energy from. The spring does convert the energy. It does transfer it very effectively. 99% of the energy goes into the object you just moved. Anyway, it's just terrible. All right, so DraftScience, he's saying to me, so I haven't read any of this. I just said these people are, insane. No point. I figured I'd read the comments and just say, I can't do anything. I can't do anything for you. Okay, you want to keep defending something paradoxically, insanely silly? Go ahead and do it. Can't stop you. It's what Newton's second law is saying. No, it really isn't. Newton's second law really just applies to the idea of gravitational acceleration. I don't think he was talking about anything else on Earth, really, because everything else, acceleration can be so, it doesn't mean anything. You can't even measure the acceleration. It happens so quickly. They wouldn't even have he couldn't swing a pendulum to see how fast the acceleration was between the kinetic balls. So it's a gravitational statement, and it really shouldn't be applied to all over the place, because it's not some statement about how force is transferred between objects that collide with each other. It's what happens to objects that are being in a force. They're not banging into each other. The moon isn't banging into something else to gain its momentum. A force is being applied. A force moving the speed of light. It's not the same circumstance. And I think Newton would be raising his hand saying, wait a minute, you're really fucking it up. F equals ma is not supposed to be applied to kinetic balls bouncing into each other. All right. Newton's second law, you will see that it is not, you will see it will not compress the spring the same. So here again, he's saying something that just can't make any sense. I mean, he can't actually think that all I have to do, like I said, I compress the spring, I get more energy out of the spring. All I have to do is put a lighter object in front of it, and I get more energy out of the spring. Twice as much energy. You can't believe that's true. No, anyway. But it looks like you don't know how to use Newton's second law. So again, all he cares about is this crooked, bent, silly math. And again, as I pointed out, there's no mathematical derivatives in the creation of this formula. This formula was made out of essentially religious notions about how force and gravity work. But okay, so second law, and solve such a simple problem. So again, the simple problem for you to solve now is, we have for all these hundreds of years had this really easy to access energy making machine. You know, all we got to do is just make a pendulum and just pop the weights on and off, and we're in business. We're making free energy forever. That's the problem you have to solve. Okay, weight is mg, momentum is mv. So weight isn't mg. It really isn't. Okay, gravity is just a standard we can use for the units we put the weight in, but it's just telling you mass. So mass and velocity, mv. Anyway, so you're saying that mg equals mv. Well, it certainly does, in the sense that there's, you know, if I said there's no velocity when an object is sitting here on top of the Earth, well, do you really think there's no velocity? The whole point is that obviously there is a velocity. There is a velocity into the Earth, and the Earth pushes us back, and we feel it every day. Every day I feel the Earth pushing back at me. I don't feel gravity pushing me down, but I certainly must have a velocity if I'm going into the Earth, and the Earth has to go to the trouble of pushing me back out. I must be having a velocity of some kind, right? So that's the 1 unit of velocity. I'm getting a gravitational unit of velocity, all right? And so in that circumstance, I can measure my mass, because I'm getting a standard amount of velocity. A simple way to solve for that. Anyway, so G equals V. Well, there's no doubt about it that G does equal a V. G creates velocity. In 1 second, you will gain a certain amount of velocity, and on Earth, you know, surface gravity, that velocity is whatever, 22 miles an hour, which of course is wrong. Again, weight is a force, so he says weight is a force, which is too silly. I mean, it's just too silly, right? The velocity is applied to your mass. Its mass moving is your weight. Anyway, momentum is not. Well, of course it is. Again, it's just as simple as I can put the apple on the scale. It has a weight. I can drop the apple a meter onto the scale. The scale will jump to a high number and say, there, that's its weight. The apple weighs this much. So when it first hits the scale will bounce up, and that number will tell me what's the momentum of the apple. So clearly a scale that's measuring weight is also measuring momentum. All right. According to Newton's second law, so he's just going to keep saying Newton's second law, which doesn't, like I just said, it doesn't, you can't apply it in any rational way to any of these physical linear equations. It doesn't work. It doesn't make any sense. Cars crash into brick walls. None of that crap has any meaning in that circumstance, because the deceleration is happening at such a time scale that is so minute that you couldn't even do the integral. All right, anyway, according to Newton's second law, but maybe you don't know the Newton's second law. Again, I'm arguing that it's a generalization for a certain circumstance, and it really doesn't have anything to do with all these other circumstances. It's really about gravity. It's about telling you how much force something collects while it's in gravity. It really doesn't have anything to do with anything else. You're effectively saying two objects can have the same weight but not weigh the same. Oh, that was my quote. Okay. No, I'm not. Yes, you are. Okay. You come up with this conclusion because you said this. Momentum is essentially weight. Yes, exactly. It is. It can be measured just like you measure weight. You measure it exactly the same way. But you said this stupid thing because you don't know that Newton's second law. So he says it again. Go and read it. So again, there's no law, first of all. And again, what was Newton's application of F equals ma? You think he applied it when in the Newton's cradle? What would the A be? 0? I mean, I mean, theoretically, let's just say the A is to replace a percentage, right? So we know gravity, the percentage in the first second is you go half the distance. Okay, so we know the acceleration is going to be some 0.5 kind of number, because you don't get the full distance in the first portion of your acceleration. But what's the acceleration going to be when two steel balls collide with each other? What's your F equals ma solution to that problem? I mean, the A is going to be irrelevant. It's going to be a 1. All right. So Bob Rill says okay. No, I don't know. So PBS says okay to whatever Bob said before, which was something like, okay, I'll go along with whatever you say. This can't be demonstrated with any credible experimental example, so I just repeat the same thing, okay, as evidenced by the fact none has been provided. So again, nothing, not a single piece of evidence that I can compress springs more by just putting lighter things in the experiment. Okay. Bob says sorry for the confusion, which I don't know why you're conceding to their nonsense, Bob, but bad move. Alright, so then William 1986, dork dumbass, that'll be my new name for him. No one is afraid of the experiment. Well, apparently you are. I mean, obviously, if I do the experiment, in my crude way, you'll all complain that I fucked it up somehow. So the idea is to pay somebody to do it really well, like maybe even film it with a high-speed camera. So we can see every little detail, get it all perfect. Because, I mean, it's a cornerstone. Again, it's one of these cornerstones of your physics, is this stupid, idiotic formula that is idiotic. And you should just concede, like I said. I mean, the simple truth is that we didn't have all this rocket science, back when this nonsense was invented. And I can guarantee it, NASA's not using your formula of kinetic energy when it's deciding how much thrusters to use. It's not paying any attention to that nonsense. All right, anyway. We can go ahead and do it. We can go ahead and do it. Well, again, we can. But it's notable how you say it can't be demonstrated as if you already know the answer. Well, of course, I already know that infinite energy creation isn't possible. I know that perpetual motion isn't possible. So I know you're dead in the water. Okay, you're just already, there's no way you can be right, because then I could just, I don't have to pay my fuel bills anymore. I don't have to pay any bills anymore. All I do is make myself a little device that simply replaces heavy objects with light objects. Compress a spring, put in a light object, I doubled my energy. Compress the spring again, put a lighter object in, doubled my energy again. The paradox is sitting there right in front of you. Explain why it's not a paradox. Explain how your formula doesn't create a ludicrous paradox. Okay, but it's notable how you say it can't be demonstrated, as if you already know the answer. Yes, when you actually don't. Well, like I said, I actually do know the answer. I've seen it all my life. I mean, I was never fooled by somebody telling you, well, if the car's going twice as fast, it's 4 times the energy. I never fell for any of that crap. All right. I mean, I do know that, if I increase velocity and I become like a bullet traveling through space, that I'll tear into other things, rather than me getting destroyed, they'll get a hole drilled in them. So I did understand that principle of velocity, that it does give you advantages in collisions. I mean, but it doesn't give you an advantage when it's, your bullet against a steel brick wall kind of thing. All right, anyway. So PBS is chiming in. All right. You said that Newton is correct and the prediction that Newton's law is made about the problem. Oh, I just write so poorly. Okay. You said that Newton is correct and the prediction that Newton's law is made about the problem is that the compression will not be the same. I said the compression will be exactly the same, so you're a liar. Okay. Again, use Newton's second law if you know what is saying, but it looks like you don't. So again, he just keeps saying Newton's second law, Newton's second law. Newton's second law doesn't say you can make free energy, idiot. Alright, so now you are saying that Newton was wrong. So that's just a lie. So there's nowhere in Newton's, again, there's nothing about Newton that had anything to do with this idiotic equation. So again, don't keep arguing that somehow Newton created this derivative, or Newton thought that was a great idea, or that Newton thought the universe worked that way, or Newton did silly gravitational experiments where he says because it goes 4 times higher, it has 4 times the energy. Newton wasn't an idiot. I'm sorry that you kind of are. Okay, about his second law. The same to you when you are saying is wrong because can't be demonstrated with any credible experimental examples. Again, that's not my fault. You've had, again, your physics has existed. Millions of people doing, millions of experiments. It's kind of funny that you don't do any of the ones that make your physics look ludicrous. So it's not a huge surprise, I guess, that you don't make those kind of experiments, public too much, because the obvious paradox is obvious. So I'm just saying, obviously, a physics teacher isn't going to do the experiment because they have to explain to his students why, oh yeah, this formula I'm selling you, it's complete nonsense, because look how fucked up it is. Of course, they're not going to do the experiment that shows it to be a complete nonsense. I mean, they're not going to do it often enough for us to see it. But I'm just saying it is simple enough that we really can do this, as evidenced by the fact that none have been provided. So again, it's my fault there's no experiments demonstrating it. No, it's not my fault. And again, I'm all for doing the experiment, but I'm all for you paying for it because you're wrong. I'm for whoever's wrong paying for the experiment. That's my argument. I shouldn't have to pay for it. You should, because you're the one who's going to be shown to be a fool. Forget what I say. Forget what I say. Do an experiment to verify what you say. Well, I've already argued that, yes, let's do that. Why is it so difficult for you? Well, again, it's not difficult for me. But again, what are you going to do if I do the experiment on my table and it's close enough? You're just going to argue, you didn't do it right. You cheated. So, anyway. You are saying that two bodies with the same momentum will compress the spring the same. Demonstrates this with any credible experimental examples if you can. So again, he's overtly asserting that the lighter object will compress the spring more. Even though the same exact spring produced the energy, it will magically do more. It will magically have more energy. So all I have to do is put light things in front of springs. All I have to do is put lighter bullets in and I make more energy. So Ribble says again, no problem. I'm not liking you very much there, Bob. Yeah, no, I'm not liking you much. Alright, William, he knows the answer, which is absolutely that he is wrong. So again, I just wish somebody would explain how it's possible to be wrong. So you're arguing overtly that perpetual energy creation, free energy creation is possible. And with this very simple device, we just take a big giant 1-ton thing and we just roll it into a spring, and then we just let the ball fall off the track and we just replace it with a 1/2 ton and then let that spring push it, and we've made bazillion joules of energy. I mean, it's probably an easier way to do it, but I just mean, so all we have to do is keep banging heavy things into light things, theoretically, and we can just make all the energy the world could possibly need. So he tells others to do the experiment and does not do it on his own. So again, it's just a lie. So you can't help. See, this is where they just can't help lying. I made 3 videos where I've pointed out overtly, let's raise the money. I'm willing to bet. Are you willing to invest in your physics? I'm willing to invest thousands of dollars. So you pledge that you're willing to pledge a certain amount of money, and I'll meet it. Okay, and then I'll take your pledges, once I know that I'm not going to have to be stuck with the bill, and we'll just ask anybody who wants to do the experiment for $1,000. Here, we'll pay you $1,000 to do a well-done experiment. We'll contract the experiment done, all right, and I'll use your money essentially to do it because I know I'm going to win. All right, because if he does it, he will not be able to say later that the results is wrong. So this is bizarre. I've overtly made videos pleading exactly this, that we get the experiment done nice and clinical and right. And then he's claiming, oh, why don't you ask somebody to do the experiment right? But if I show him an experiment, then he will just find an excuse why the results are wrong. Well, guess what? If you show me the experiment, that is, you put a link in here and I go to the link and everybody sees the link, then what's going to be seen is they'll see me making up some excuse why your perpetual energy machine doesn't really work. Okay, and they'll see that because you'll be sitting there proving that, hey, I made free energy. Okay, and so, you know, I'll look so lame claiming that your free energy machine doesn't work, right? I'll look like such a fool arguing against your free energy machine. I mean, you people, could you, I mean, is it really possible for you to go lower and be more pathetic? All right. So I think that's all there is, right? Yeah, that's all there is. So PSB does actually believe that all I have to do is bounce it in, bounce it back, and I can make free energy. So all I do is I compress the spring, all right, with a weight. So I just have a weight, compress the spring, I lock the spring, I replace it with a lighter object, and I can make twice as much energy. He believes that's the truth. Which is real, I mean, he must believe in Sasquatch and UFOs and lots of other things too. Probably a flat earther. I wonder if, I guess William is the same, you know. So I'm saying there really shouldn't be anyone defending that notion. And that's what you have to defend the equation. So until you explain where I cheated, where it's not true, that's the exact implication of your theory of energy. And you've got to see it just by looking at the formula. It's so lopsided. How can you justify thinking that the mass is very unimportant and the velocity is very, very important? How can you, with your brain, think that can possibly be how the world works? That all I have to do is keep making lighter and faster things, and I give the the universe more energy. How can you think that's true? It's so stupid. Alright. Yeah, so I've done all I can do. Yeah, Captain Grubb says, this is astounding to me that it could be so obvious yet missed by everyone for so long. Yeah, well, I'm just saying that in the past you can see how it could get missed because this question never went to the Royal Institution, technically. It really wasn't debated in England. Because they knew all the Newton people would say you're full of shit and try to shoot you almost because it's so stupid. So they knew they couldn't do it there. So they did it in France. Okay, and they did it in a very biased and one-sided way. And that's what it all comes down to. The judging of people's arguments were by people who had a bias. Okay, and it's that simple. And then it just grew from there. The whole chick thing, and and Voltaire, although he made good arguments, he wasn't, a physicist, and he just didn't have the bullets in his gun to shoot it down with something as simple as just arguing. You're arguing for infinite energy creation. So if they had just made that simple argument, then they could have dispensed with the whole thing. But they kept arguing around the subject instead of at the subject. What is the consequence of this formula being true? What does it do to the practical reality? Voltaire, in some sense, he was arguing this is just wooey religion. This is a crazy idea. I mean, he knew it was crazy. He just didn't... well, I can't even say what he did because guess what? You can't even find the actual papers on the internet, of what the arguments actually were. All you can find is people characterizing them for their own storytelling purposes. So, that's a huge flaw. Because some of the arguments, I did get a brief little piece of one of the gravity argument. I'm just trying to remember it. Yeah, I'm not going to remember it though. It wasn't bad, but I'm just saying the one that makes it more clear, I think, is just to understand that if you find some device that actually does store energy consistently and reliably, you just use that device, okay, to do your transferring, to make your heavy train hit your light train. You can't make you can't do the exchanges with actual moving objects, so you really do have to transfer the energy to a storage device and then replace it with the lighter object, and then you can do the complete transfers, minus the 1 or 2%. Well, anyway, it's just unfortunate. So he says, I always dislike Leibniz, but completely different reasons. Well, they're really probably the same reasons, something to do with his objections to Spinoza. I mean, clearly Leibniz was a relativist, it's sort of a, I don't know, a wooeyist, in the sense of this whole idea of a living force, that there was some innate thing about the universe that compelled things to move, and it wasn't exactly correct. So anyway, I mean, it wasn't grounded in a mechanical universe. Yeah. It's hard, it's what happens to anybody, right? So just as Newton was perverted, I mean, in some sense, Leibniz's original idea was used by others who had even more egregious notions about the elemental function of the universe. So it's hard to separate the people who defended Leibniz from Leibniz and the limitation of what he might have been saying overtly. And again, this all just comes down to gravity being perceived as if gravity was like all the other things that stored energy. Gravity doesn't store energy. How to put this? I mean, magnets are continuous forces too, but you can't, if all you had was the attraction between magnets, you wouldn't be able to make a magnetic mechanism to store energy, because you wouldn't have that repulsive pressure. So so that's just the huge limitation of gravity, is the one-sidedness of it. But yeah, I don't know how else to say that. But if they understood gravity as just being rain, and if they understood mass as just being a bucket you collected in, they would have understood that small buckets, small capacity to collect. Simple. Alright, anyway, that's enough of a video, I imagine. Yeah, so we'll just see what happens. I mean, I'd love to discuss this with somebody who wishes to be, in some sense, civil and explain, if they have any way of explaining. But I mean, the thing you have to explain is a paradox. So just until you explain the paradox, what's the point? I mean, if you're going to tell me that, like I said, you have to come up with some sort of magical excuse why one spring didn't know that the other spring was supposed to be compressed twice as much. I mean, it's just not possible to make it make any sense. I mean, you can't shoot it with one spring compressed this much, and then it lands at the other spring and compresses it even more. I mean, losing energy is one thing. Gaining energy? Oh, come on. And that's the direct implication of their argument. Again, if Physics Girl had just done the opposite experiment, so to speak, one train hits another train, they both go off. If she had done the opposite experiment, she'd have to explain where she gained energy. Alright. Well, no, this is astounding to me. I mean, that statement, it astounds me. I didn't think I would find something this obviously pooey. I mean, where they've taken something so stupid and ingrained it into their whole physical concept. I didn't think there would be anything this egregiously dumb in the physics. I mean, that is kind of remarkable. That all these years, all these physicists have just sit there and accepted something that made no sense. It just can't make any sense. Momentum doesn't matter. Somehow you have two definitions of energy and they get different numbers, and that's okay. I mean, how could that make sense to anybody? Even a mathematician. I mean, how can they make that? How can they force that to make sense? They obviously aren't compatible. Why are they pretending they are? They should have finished the fight, 200 years ago and just said one of them's right and one of them's nonsense. But to keep both of them is just too idiotic. Well, anyway, yeah, so that's it. I can only do my part. I can make arguments, and you can make nothing as an argument in return. That's what I'm going to get, I guess. I guess that's all that's going to happen for a while. But someday, you're going to be accountable. Someday, there'll be some physicist in the wilderness who will admit the truth, who will be have the balls to stand up for the truth. This has been a Draft Physics, Draft Science here on YouTube video presentation.